Okay, this is a video for Math Models Unit 5, Lesson 8. I'm going to show you how to use a web app to do binomial probability. Binomial probability is a situation where you have two possible outcomes. You have one that's a success, one that's a failure, and we need to know how many times this one thing's going to happen and what the probability of that thing happening 5 out of 6 times or 99 out of 100 times. And so there's basically 3 values that you need to know to do these. So I'm skipping all of the detail up here. But all this explanation is getting us down to is we have 3 values that we need to know. We need to know the n value. We need to know the k value. And we need to know the p value. And so we're going to talk about what each one would be in this problem so you can begin to understand what they are. I know my writing is messy. I'm using my fingers here. So it says if you flip a coin 50 times, that is n. N is always in math the total number of something. What is the probability you will get tails 35 times? That is k. So just to stop for a second, n is always the total. K is always how many times you want to get the thing that you want. We want tails. How many times do we want tails? 35 times. And P is always the probability of that thing happening. We know on a coin that the probability is 0.50 or half to get tails, 50-50. So these are the 3 numbers you need. So we're going to take this and we're going to jump over to the calculator that I'm going to post a link to in the video description. And we're going to do n. So, so we're going to jump down the page and you're going to have a spot here where you can put in values for n, k, and p. And so again, n, right, is the value 50. That's the number of times we're going to flip the coin. We want to get tails 35 times. That's k. And it's a 50% chance of getting p. Q is going to calculate automatically. Q is whatever's left from p. So 1 minus p gives me q, but you don't need to worry about that. So we're going to calculate, and it does some stuff, and there's a bunch of information down here. But it gives us 3 things. It says we can get the p of getting exactly 35. We can get the p of getting 35 or fewer, or we can get the probability of getting 35 or more. So it tells us it wants to know what's the probability of getting exactly 35. So let's jump over here. Exactly 35 is right here, 0.001999. Okay, 001. Okay, so now I have some issues here. So this is a little bit of a weird deal, but you need to use some of your basic math knowledge. You're not going to have this issue on the other problems in the unit. But we know that this written in scientific notation, we'll see if Desmos will do this for us, is, let's see if it'll do it for us. I don't think it will, unfortunately. That's okay. I was going to try to do scientific notation, but I do that in math. We do scientific notation, we're moving that decimal place 1, 2, 3 times. And so we're going to get 1.99 times 10 to the third. But basically, 10 to the negative third. The only one of these that's even close is this 2. Because we had 0.00199, if I round this, I'm going to get a 2 right here. And that's the answer for this one. So I'm glad I did that one for you because that is a weird answer. The other ones, you're not going to have the issue. They're all just straight decimals, maybe except the last one. But I'm going to do one more, and we'll talk a little bit more about how we do N, K, and P for this one. So the next problem says you're taking a quiz with 10 true or false questions. So that's our N. Right away, I say, okay, N is 10. There are 10 true or false questions. What is the probability you'll be able to choose a random answer on every question and get 9 or 10 correct? So 9 is my K. And since it's a true-false quiz, there's two options. So the probability is 0.5, 1/2. So I click calculate, and they wanted to know 9 or 10 correct answers. So that means 9 or more. So I'm going to use this one down here as my section that I'm going to use. And it says 0.01074. Oh, so it rounded, which is fine. But this one's got to be the answer because it's the closest. The other ones are way off. But again, that's an N of 10, a K of 9, and a probability of 0.5 because of true false being the type of question. I'll do one more just to drive the point home. Here we have a problem. Your multiple choice quiz with 5 questions. Each has 5 choices. What is the probability you will be able to choose a random answer on every question and get 4 or 5? So the total number of questions is 5. And I want to get 4 or 5 questions correct. So 4 or more, but 4 is the K. And since the problem, each choice has 5 choices, each question has 5 choices, that means there's 1 out of 5 or 0.2 probability of guessing right. So I got that by saying there's 5 choices and 1 out of 5 is correct. So then 0.2 is the probability of getting a correct answer, just guessing. So I calculate, okay, and they want to know 4 or 5, so 4 or more. So we get on here, 4 or more out of 5, 0.00672. And there it is. And so that's what you're doing for the rest of these. You have your N, you have your K, and you have your P. So N is the number of things, K is the number you want, and P is the probability in a decimal form. So I say that because right here, 0.8.8, you need to convert that into a decimal. So just be aware of that. And same thing down here in number 8. And I think that's the only one that has percentage. Oh, there's another percentage in 11 and 12. So just make sure you're converting any decimals to percentages, or sorry, any percentages to decimals before you put the p-value. And just to remind you of that, if you have a decimal of like 12%, or if you have 12%, if you divide that by 100, that's the decimal form right there of 12%. So be aware of that. You would put 0.12 if you had 12%.